so important for augmented reality in particular. And this really comes down to the fact that AR is a spatial computing medium, right? So there's stuff in physical space. And part of the reason why this emerged in the hardware space, this concept of rapid prototyping, is because the idea that you have in your head about a thing often will gloss over little hitches that might actually exist when it's in real space. And we see a lot of parallels to this in AR and VR and spatial computing, where you need to kind of see, is it the right size? Is it moving correctly? And the ability to sort of will something into existence is a really powerful iterative tool in AR. And it's really hard to nail something without kind of doing that iteration in space. Now, you can do rapid prototyping on things that are not augmented reality. It's sort of a design tool that gets used. But we find that it's almost impossible to come up with a quality feature or product without using this technique for AR. And if you're building a feature, you're using rapid prototyping, where does it fit into the product lifecycle? And we typically find, and this maybe is better said as the feature lifecycle, this is right at the beginning. So you're not going to be rapid prototyping like 2 weeks before you push into production. Like that's, unless you move really fast, I guess. What you're going to do is you're going to start out right when there's a user need that's been identified. And you can ask yourself, will this be serviced well by augmented reality? Is this something important to do in my product? And then you can begin kicking off these rapid prototyping cycles to convince yourself that it's worth putting on your product roadmap, right? So we're really talking about the area from idea to it's like on your ledger as slated to be built. And when I go through here, I'm going to talk a little shop, which is basically I'm going to give you these 3 things that we've just found to be true generally about working in this rapid prototyping process. And then I'll run you through some of the tools that our team likes to use. It's not an exhaustive list of all tools, but it's our favorites. So the first observation that we have is that rapid prototyping is fundamentally a process that is about speed, and people are critical for speed. And it's not just having the right amount of people, but it is also having the right type of people. So when you're doing these quick iterative cycles, a big team is really hard to manage, right? We work in super small pods of like 1 or 2 people, maybe 3. And what that means is you need to like level set with your partner a lot less because you're in constant communication and there's nothing gets lost in the wires. And it helps you be a lot faster. But the flip side of this is that each person needs to be able to kind of do more because you have fewer people working on a prototype. And so that means you need to have like the right kind of people who might have some crossover skills. The next is that you need to constantly be testing when you're doing rapid prototyping in AR. So it's this, it's a very physical medium, right? You're moving around or you have a headset on. And we do a lot of work with phone AR. But there's like, you rapid prototype and then you have the prototype and you test it. But there's also these in-between steps between starting and having an iteration where you just have to constantly be offloading onto your device so that you can actually get the feel for it. Because otherwise you build up this backlog of stuff that you've made and assumptions you've made about how it's going to work. And if you reach your iteration endpoint, you're like, all right, let's see how this iteration went, and it doesn't work, it's kind of hard to detangle what might be the thing that's making it go off kilter. And last is that scope is critical for delivery. So we all want better scope in our lives and our products. But in rapid prototyping, it is especially key. So this is both in setting scope when you start the prototype, as well as making sure to come down with a strong axe and keep the scope from creeping. This happens all the time to us because there's, new technology will come out to enable a new thing, or midstream, and this feature that we're developing will realize there's this big opportunity. And so there's this temptation to, oh, we could do that, and oh, we could do that, and you end up getting all this cruft along the way, and eventually you're kind of just prototyping, you're not rapid prototyping. And so sometimes it's right to expand scope, but you should always be aware when you're doing it and be justifying those decisions in a meaningful way. So now I'll dig into some of the tools that we like to use. Starting on the top left up there, you see the sketch icon. So 2D design tool, fact of the matter is, even though we're living in the cool spatial computing future, there's still a lot of 2D UI that gets made. And there's a lot of world space 2D UI that exists as well. So our team spends a lot of time in Sketch, both to do early illustrations of flows to get our team on the same page, as well as to just be ripping assets out to these other cool prototyping tools. Which brings me to the top right, which is Unity, which is rad. If you don't know about Unity, you should check it out. It's basically what gives our team the superpowers to work super quickly. So Unity is a 3D game engine, and pretty much every AR thing you can imagine has SDKs that'll help plug directly into Unity. And it solves all the hard stuff for you, right? It solves, the AR frameworks solve tracking and all that. And the game engine solves a lot of the problems that you have with 3D, like how do you render a 3D model? What should my shaders be like? What if I want to implement physics? How do I do that? And you just don't have to think about any of it. And I'll get into a little bit of why that's so important later. But we almost always have Unity up on our computers. Taking a step down, we see After Effects. That's that purple box on the left. And the key with rapid prototyping is that you don't always need a fully working thing. Ultimately, a prototype is a communication tool for you to either understand what you're building better for yourself, or to better articulate what you're making to someone else, or to see how someone else will use it. And you don't always need a fully functioning prototype for this. We can make video mockups that sometimes get us all the way there, and they're often much quicker. So we pull out After Effects when we realize that there's actually no need to touch this. We just need to see what it would be like in a space. And sometimes you can do that when you're playing with scale, sometimes you can't, but it's a good tool to have. Moving to the right, Principle. This is good. It's a good in-between between sort of After Effects and Unity, where you want someone to be able to touch it, but you don't want to spend a ton of time like actually coding up like a really robust prototype. And it integrates super well with Sketch. So we find ourselves pulling that one out fairly frequently as well. And these bottom two is a bunch of Legos and a little symbol I put in there for basically paper prototyping. I know that like I myself am guilty of trying to be like, oh, I know technically how to execute on this, so I like jump into code in Unity and start building stuff. But often the early assumptions in like a feature's lifecycle can be validated using physical prototyping methods, like putting like blocks of clay in the correct position, or creating a structure that is at the scale you think and figuring it out that way. Or as you'll see later, even applying physical labels to objects to try to understand like type scale to world space type things. So those can help you move really quickly, and it's easy to forget them because we live so much in like future cool tech land. But to dig more into that, I'm gonna hand it over to Diane to swing you through what our process looks like in a little cycle.
Nice, thank you, Austin. So let's jump in and open up what one of our processes might look like. And I think I'll start with the high level, but these are the key building blocks that we have in our toolkit. And what we do is when we come and are thinking about a new problem that we want to solve, we take a look at our toolkit and we put together the pieces of these different methods depending on what is most suitable. So when you are approaching your own rapid prototypes, think about it that way as well. You're probably not going to want to go through every single one of these because it might not be appropriate for the time scale that you have, the types of problems that you're trying to solve. So I'll go into each of these different stages and talk about what we try to get out of all of these too, so you can do that. But from a high level, we always start with a brainstorm. So this one, like, don't take it out. We always ask ourselves, where are the AR opportunities? So this is when, as Austin was saying, we try to think about the different perspectives that each person brings into the brainstorm. And we try to have a really good set. So people that bring diverse perspectives from different functions, but also people who can really empathize with your user group. That's always really great to have at least one or two of those people in the room because they can help ground you when you're coming up with ideas. So the second stage, and this often takes place during our brainstorm, is we start to talk about the different ideas that we're excited about. So we narrow down the ideas that came out of the brainstorm, and we think about it from a number of dimensions. So why is this better in AR? What does it take to get this to happen? And what might this look like? And then after we decide on the ideas that we're excited about, this is a smaller set, but it's not a definite tiny set that we're only going to run with, because we like to carry a few of our ideas through sketches and through early low fidelity processes before we make the full decision on which ones that we kind of ship to production. And so this next sketching part is when we take that smaller set of ideas we're excited about, and then we sketch them from kind of the full journey. And we think about the physical space, but also the digital realm. So what are the entry points? What are the touch points of the user? And how does that carry through? And then Austin was talking about physical testing, but this is relevant for some of our features that are really closely tied to the world space. But we also like to just really play with physical objects and physical prototyping when it's applicable, because a lot of times that's actually going to be a lot faster than you trying to get that to happen through your digital tools. And then right after this part, we jump into design and development simultaneously. But Austin was saying we often like to pair together people who know how to code, but also know how to design. So you get a lot of the back and forth collaboration, and you can get out some kind of a working concept really, really quickly. And then this testing early and often is an approach that our team holds near and dear to our heart. We test as much as we can, and that can be as lightweight as just showing a prototype to someone next to you, or it can be actually validating with users in the field, and that can be anything that's super lightweight to maybe a really robust study, depending on how well you know your users and how many assumptions that you're making. And then we bring everything together as we polish and think about supporting functionality as well. And that's where we start to bring together all our pieces. And this is just for our prototype too. So we really like to make sure our prototypes are polished to a point where it can be, where we can share it to a broad audience. Cool. So jumping into the individual steps, our first one is brainstorming, and this is a photo of what that might look like in our typical day-to-day. So we brainstorm a lot in comparison to other teams. And so what you see here is me just putting a Post-it on the board, but we're doing a method here called affinity mapping. And what that lets us do is everyone can brainstorm and put their ideas on the wall, and then we group them together to identify the key themes that are appearing across the group, and then we can have discussions about those broader themes. And then we jump into deciding. And so what we're doing here is, you can see there are some stickers on the Post-its, but what that's doing is it's really helping us identify which ones have the most interest from the group. So we don't let these decide the ideas that we run with, but they do give us a great starting point to facilitate a conversation. So if a lot of these themes that we're excited about are all in the similar category, as a group in the room, we could start talking about why might this aspect be exciting to us, and are these the ideas that we're gravitating toward, and is this a good direction for our effort? And so after we get some kind of set of ideas that we're excited about, we like to carry them through the sketching phase. And sketching is one area where you see AR starting to be quite different from traditional 2D designs, because you can see that I'm sketching some UI elements that are pinned to world space. And so this is where you start to think about things like scale interactions that you might have to test out through like After Effects or Principle. A lot of those micro pieces that you might not have thought about, those are all pieces that come together in AR. And so what we like to sketch is the full end-to-end of the journey. So everything from the user, who they might be, what context they're in, and it's not just the context of their phone and their screen, but the context of the person. So they might be in a location or a certain place, or they might have come out of a certain situation. And those are all things you want to capture in your sketch. And those are potential entry points for you to enter into any sort of AR experience that you're thinking about. And so we carry this through end-to-end, sketching the context, the whole experience, and also like what is the full solution that you're looking at. And so something else that might come into play here is real-world testing, so physical prototyping. And this is something that our team has done, but if you're working with augmented reality and something that interacts so closely with the physical world, a lot of times it's faster to just cut up a piece of paper and to try something out in world space in the fastest way. And so what you're seeing here is a translation concept where, for example, if you scan some objects and we know what those objects are, we can translate them in world space. And one of these questions that might come up is, do these labels make sense in world space, or might they be pinned to your screen space? And one way to try that out really quickly is to just test something out in world space, see what they feel like when they're pinned to the object. You can try out some micro interactions too. For example, how might this feel if they rotate when your screen is facing a certain direction, or how might they appear? So you can try out different motion curves too really, really quickly, just through a quick video and paper. And then our next step is, after we're finished with our really early sketches, we jump into design and development to develop our prototypes. And so Austin covered some of our tools, but the classics that we really stick by are using Sketch and Unity. And we use them pretty much side by side because Sketch, what it allows us to do is it covers a lot of our 2D aspects and a lot of our quick mock-ups to just communicate something across. And the Unity is pretty much everything beyond that. So as soon as we start talking about anything that's interactive with the world space or anything that just needs to push beyond the 2D planes, we start to bring those into development. And so oftentimes we'll have a prototyper working together with a designer, or maybe it's just someone who knows how to do both. And it depends on the concept too. Some of them need to push farther into the technical dimension, and some of them need more of a design exploration. So a lot of times we'll bring that up when we talk about who should be working on this concept too. And then here's a photo of Austin testing early and often with just things that we have around the office. So this is testing from every dimension, testing it by yourself, testing it with the person next to you, testing it with real users. We try to incorporate this as much as we can. It's especially important for AR because as much as you think you know augmented reality, you probably don't know a lot about it. Just because the technologies and everything that you're incorporating into your prototype are probably emerging as you're working on it. So use this as a way to not only answer your questions, but to uncover questions that you might not have known either. Cool, so the last step that I'll talk about is polishing and thinking about supporting functionality. So as a result of testing, you're often going to get a lot of feedback. And you probably won't have a lot of time to incorporate all of the feedback because by the nature of a prototype, you're trying to get a proof of concept out as quickly as you can. So one thing that you're going to have to do is to prioritize the feedback that you get. And so a lot of the things that we prioritize at this stage are things around entry points, how much should we mock that up or like have that incorporated into our prototype. And also when it comes to polish, how much should we be polishing so that it's not distracting to the concept so people can actually experience as much of the concept that is in front of them. Cool, so that's our process. That's a process, and generally what we do on a day-to-day, we're at some point in that process, but I'll hand it over to Austin to talk about 10 tips and tricks for
Sweet.
you.
You can put this one on my clickbait resume. Okay, so here's 10 tips and tricks. These are all things that we have either observed or that we use to basically make sweet AR stuff. So the first is that common visuals are key to collaboration. And the reason for this is partially this byline, which is that, you know, our vocabulary to describe spatial stuff, like we live in the world, you think we'd be good at it, we're really bad. I have words like, oh, that's really big, or really, really big, right? But it's hard to get too specific. And what you'll find is that if you don't establish a common visual early, it's really easy to be totally jamming with someone, like think you're on the same wavelength. I've had conversations for 1 hour plus where we're like, yeah, and then this, and we're riffing, and then I go to start to sketch it out, and they're saying like, whoa, that's not at all really what I had in mind. And the best way to avoid it is to just get visual as early as possible. And that could be like talking about, oh, it should be about this big, or doing a sketch. Anything you can do to get visual early will make your conversations faster and better. The second tip is to hit the ground even if you're not running. And I will admit that our team is guilty of this, of not doing this occasionally, which is you get really excited about a concept, you start talking about it, right? And you're just, oh, this would be really amazing if we did this. And then you keep going and you've been talking about it for hours, and I find that it often devolves into, like, I don't think people will really understand if we do that. Like, we need to do it this way. And if you're getting to that point of your conversation, just start making stuff, right? Because even if it's a rocky start and it's kind of like a hiccup prototype, it creates this common kernel that you can discuss. And anytime you hear someone say like, oh, I don't think blah, 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 you might as well just make it and see if that is true. Because oftentimes there are surprising things in spatial computing. Number 3 is that lo-fi is great, but there is a limit. So when we talk about like low fidelity, lowest is like a sketch. And then in more traditional app design, we're doing like wireframe and then visual design. And we find that in AR, a lo-fi prototype might be putting a cube on a table instead of a specific model, right? Just to have something there or not have these final visuals. But usually there's a point in a prototype in AR where it's worth it to bring it high fidelity. And it doesn't need to be in like beautiful crystalline production detail, but the devil is often in the details in these AR experiences. And especially when we're doing user testing, we find that a medium fidelity prototype often doesn't quite get there. Whereas if we just get a little bit more crisp about the visuals and what we're presenting, that actually makes a big difference in terms of how much people understand what they need to do, because those little subtle cues are so important. Tip number 4 is that having a design framework is a speed multiplier. So we're from Google, we use material design, it's rad, you can use it too. But if your company has its own sort of design style and you have a sticker sheet, abuse it, use it, because when I'm building a prototype, I do not want to talk about does that button look good? Or we should be switching around our typeface. That's sort of orthogonal to the conversations I want to be having, which is the harder challenges around spatial computing. Is this concept working for our users? Is this concept working from an interaction design perspective? And if you have a design framework, you get to avoid that, and you get to bust out these designs really fast, because you can just rip assets straight into Unity. I have a whole material design Unity starter pack I use for every project. The 5th is that we combine design and development right from the get-go. So obviously, design and development have a relationship in any sort of software development cycle, but it's particularly important in spatial computing, at least from what we've found, that they begin at the same time and that they are constantly happening at the same time. So one thing we do not do is create a sketch and then create a bunch of designs and then give them over to engineering to execute on, and then engineering is like, hey, what do you think about this? And that's not how our conversations work. Our conversations work more like I will sit down with an engineer, because I'm a designer. I do a lot of coding as well, but we work in small pods. And I'll say, hey, what do you think about this? I'll sketch it in front of them. And we will start, we build the repo at the same time we start the new sketch file. Because there's this conversation that happens where, let's be real, there's some technical limitations to smartphone AR right now. The classic example I always give is, when we turn the lights off, tracking becomes very difficult because we don't have enough feature points to perform well. And so you can either choose from an engineering perspective to say, hey, we got to figure out how to do this, let's default back to our other sensors, or maybe we need to put a depth camera in there, do we have that? Or if the designer is there, they can say, actually, if you can tell when the lights are off, I can just create a flow to ask the user to turn the lights back on or go to a more well-lit area. And it goes the other way as well, because the technology develops so quickly that the technical side really helps inform what's possible from a design perspective. And so as the prototype develops, new things will come up, and these two sides kind of help compensate for each other. It helps us move a lot faster. Tip number 6 is always look for shortcuts. So beg, borrow, and steal. Another title for this slide could be, we get it, you're smart, but don't let your ego get in the way, right? The thing about this whole spatial computing industry is it moves fast. We're all at this conference, but people are solving hard problems and making your life easier. And so there's no use reinventing the wheel. Keep your ear to the ground for ways that you can move faster, right? These AR frameworks made it easier to do general tracking and stuff, and there's all these developments in ML and face tracking and hand tracking, pose recognition, and you might as well scrape them out because you're not, in the rapid prototyping context, you're not necessarily creating like your production code. Like it's okay to do something inefficient from a code perspective just so that you can bust out the concept really quick. Number 7 is keep your pod small. So we work typically in teams of 1 or 2 people per prototype that's being developed. So you can go up to 3, but you start to get some challenges because that usually means you're having 1 designer, 2 developers, and then they have to start communicating and coordinating for the code base, which can slow things down. And what we really find is that we work with big teams, but it completely hinders our quick movement for rapid prototyping if our own teams get too big. And that's largely an artifact of like communication and miscommunication. Like every moment that I spend talking about what I'm going to do is a moment that I'm not actually doing it. And the whole point of this is to get something built. Tip number 8 is don't prototype native. We have AR core. It's awesome, it's rad, and use that when you're going into production because it's way lighter weight. The prototypes you build in Unity can technically be woven into existing apps and stuff, but it can be a little bit tricky. But for rapid prototyping, if you're not using a 3D engine, I think you're probably doing it wrong because it solves all of these hard problems for you about 3D, about space, and there's amazing frameworks that are available from pretty much everything you can imagine. And like, you don't want to be wasting time figuring out how to get a model imported into your scene when you're rapid prototyping, because it's just already solved for you. So we always prototype in game engines, and then there is a transition where usually you'll deconstruct it and say, okay, now how do we take the time, now that we've validated this is worth doing, and do it native, because that's going to take you a lot longer. Tip number 9, getting to there, is don't be a one-tool wonder. And as you saw on the earlier slide, we use a wide range of tools from Clay to Legos to Unity and Code to Sketch, After Effects, you name it. And the thing is these prototypes, they serve a purpose. You don't just rapid prototype because it's fun. I mean, actually, I kind of do because it is fun. But there's some purpose for the prototype, and it's to either figure something out or communicate something. And oftentimes, the more tools you have, like on your tool belt, the more likely you are to be able to take out the one that will get you just barely there with the minimum amount of effort, right? Because you want to be doing these fast cycles. So we don't always do a full big Unity prototype, and sometimes you need to be able to elevate something out of the paper prototyping stage. And so try to familiarize yourself with at least a couple tools that help you pick and choose a little bit better, depending on your situation, what you want to build. And lastly, is that unicorns have never been better. So this is a term kind of stolen from the UX world called UX unicorn, where it's basically, but it could be from development to or product. It's basically someone who can code, who has design chops, and who has product sensibility, all in one, right? It's the super ultimate generalist, so-called unicorns because they're rare. But you don't need to be a unicorn to make awesome AR rapid prototypes. This is sort of, it's a catchy way to say that generalists are really good because we talk about having these small pods. And if you have a small pod, you're going to need to have the individuals on that represent a broader range of skills that they can bring to be creating the prototype. So if you have someone who's like a really strong designer and they can do a little code, and then they can pair up with someone who's an expert in the market, those two people are going to probably make something awesome. Same if you have this like amazing software developer with some good design sense, and then you pair them with a designer, like you just move so quickly. So look out for these types of people, and if you're not one, you can become one. I think everyone can be a unicorn if you just flex those skills you're not used to. And now, those are the 10 tips and tricks. You won't believe number 6. And giving it over to Diane for some closing remarks.
Nice. Thanks, Austin. So yeah, I'll pull everything together with some high-level insights, and then we'll talk a little bit more about what we're excited to see all of you do with some of these insights. So the first one that we've hit upon a few times is that rapid prototyping is a really important skill set for working in AR, and especially because you're working across a wide suite of technologies, being able to weave a lot of those together at a very early stage helps you communicate a lot of aspects that might take you a really long time to try to get across if you're just trying to say it or trying to sketch it out. And so we've gone through a number of different approaches, methods, processes for you to do this yourself, but it's really important if you're working in this space, and we encourage you to do it even if the AR component of the feature that you're thinking about might be lightweight. Just try to get things out and have discussions about your prototypes as early as you can. And something else that we've talked about that we're excited to chat with all of you about today is that it's really feasible to integrate rapid prototyping into your process. So start with the biggest concept, which is try to start making things as soon as you can so that you can have very productive conversations early on. But for all of you, it's really easy to take that approach and to integrate it in a way that works for you. There are a few things that are really interesting that Austin brought up, which is working in small groups or getting something as quick as you can and not worrying too much about how much of it is something that's in production, but trying to push the concept across early on will really help get your feature to happen. And so yeah, it's really feasible. We would love all of you to run with it. And the last thing that we're going to leave with you today is that it's easier than you think to prototype for AR, especially today where you have a lot of frameworks that have a lot of functionality that's already built for you. So take some time and research and take a look at what's available and start to put things together. And we're really excited for all of you to do this and to see what all of you do. So thank you so much for joining us today. We'll be here for questions. But yeah, thanks.
Cheers, guys. Thank you.